Right guys, so we're back here at Bethel Church in Coventry on this partition wall. Sound insulation project between these two offices. So this wall's about ready for plastering now guys, and it's going to be completely finished. So just thought I'd walk you through why we chose this system and the gains that can be expected using an acoustic system like this between two offices. So first thing worth mentioning is the restrictions that we had when installing this product, and why we went for the 12.5mm sound block acoustic plasterboard with the timber frame. So as you can see here, we've got a door frame that's quite tight to the existing wall. So we've only added 12.5mm onto an existing brick column that was here. We've also got some electrical points, so this alarm sensor underneath the tape. We've got some pipe work as well, and we've also got a glazed unit above. And the reason we didn't want to build out too far onto this glazed unit is because if they ever need to access these beads, let me just zoom in. If for any reason they need to access these beads to remove the glass, they'd really struggle if we built out any further than what we have. So for those reasons, we've only added, again, 12.5mm of the sound block board to the existing surface. However, there was a recess here where this pencil line is, so we were able to infill this section with a timber frame, which then had some rock wool sound insulation added to infill that cavity. And again, we've clad that with a 12.5mm acoustic board. We were able to gain a 48mm air cavity between the two partitions, which has also helped with absorbing some of the sound. And the reason that the sound transfer was so bad beforehand was all they had was a 3x2 partition with some hardboard screwed to one side. So you can imagine how the sound was just coming straight through that wall and disturbing the workers in this side of the office. So let's briefly look at the sound block board and the dB ratings. So this is the sound block here, and it's recognised by the colour, so it's blue. Standard plasterboard being grey. Now this is a lot more dense than a standard plasterboard, so I just wanted to demonstrate what I mean. So it's a lot tougher. So if I just take this wood screw, for example, and I push that into the product, it's very tough, dense, and a lot harder than standard plasterboard. And that's what helps to absorb some of that sound. So this is your standard plasterboard here, and again with the screw, using the same pressure, I can easily, because it's so soft, I can easily break into the material a lot easier than the sound block board. So the dB rating of a single sheet of this sound block board is between 36 and 39 decibels. Going back to the issue of the sound transfer, standard conversation is around 60 decibels average. So if we can get near that number with this system, we're going to significantly reduce the nuisance sound coming through the wall. So how we did that, again, is one single sheet of 12.5mm sound block board. The decoupling of the two timber frame systems was around 50mm. That's going to also add to the sound insulation, help to absorb some of that sound. That gets us somewhere near the 60 dB rating that we needed. And it's worth mentioning as well that although we've got a solid outside wall here that is a cavity wall, it's made up of brick, and we've also got a solid wall here made up of brick, and quite a heavy fire door that has furrings situated around the fire door, there's still risk of flanking sound coming through some of this material. So for example, the 9mm glass pane above and the timber ceiling. We have got a solid concrete floor under this timber floor as well. So flanking sound always needs to be taken into account whenever you're installing a soundproofing system. Now obviously in a residential property, on a domestic dwelling, if we're doing party walls, dealing with nuisance noise from neighbours for example, we wouldn't use a system like this because we'd just be losing too much floor space. So we can't be adding 60, 70, 80mm onto a party wall because customers would just lose too much floor space, and that's why they often opt for the soundboard 4, the slimline sound panel, which is only 30mm in thickness. Now the slimline sound panel, when combined with a 9-inch solid wall, will give a dB rating of around 52 decibels. And again, most of the time we've got conversation, TV, radio sounds being the issue, with an average of 60 decibels. The slimline sound panel, although it's not a magic wand, like this system, it will significantly reduce the sound transfer coming through those materials. So I hope this information has been helpful today. If you have a project in the Coventry and Warwickshire area, be sure to hit the link below to arrange your free survey. Thank you.